Hi, welcome back to the session. In this video, we will discuss about Dijkstra algorithm. So another name for Dijkstra algorithm is single source shortest path algorithm. This algorithm, Dijkstra algorithm, can be solved by using greedy strategy. Now in this video, we will see how to solve a given problem by using greedy strategy. Dijkstra algorithm is used to find the single source shortest path which can be aimed to find the solution to the given problem. The problem statement of Dijkstra algorithm is find the shortest path from starting vertex to all the remaining vertices. If you want to find the shortest path from a starting vertex to all the remaining vertices, it can be possible by using solve the problem in a stage-wise manner. The Dijkstra algorithm can be solved in a stage-wise manner in the given problem or given graph. This is called as a minimization problem or optimization problem. These optimization problems can be solved recursively by using greedy algorithm design technique. Greedy algorithm or greedy method says that the given problem should be solved in stages by taking only one step at a time and considering only one input at a time to get the optimal solution. Here, the Dijkstra algorithm can work for both undirected graph as well as directed weighted graph also. It works for connected graphs also. The graph should not contain any negative edges of weights. This is one of the drawback or limitation of Dijkstra algorithm. So the main drawback or disadvantage of Dijkstra algorithm is in Dijkstra algorithm, the graph should not contain any negative edge weights. Friends, we will discuss how to write a step-by-step procedure or algorithm for the Dijkstra algorithm in this video. If you consider this is the graph, this is a weighted directed graph or weighted undirected graph. The graph is weighted undirected graph. The main aim or the problem statement of the given graph is find the shortest path from the starting vertex S2 all the remaining vertices in a stage manner. In a first stage, there are two vertices, namely vertex A and vertex C. In second stage, there is another vertex, namely B and D. So the main problem is find the shortest path from the starting vertex S to the all other remaining vertices A, B, C, D in a stage-wise manner. This problem can be solved recursively by using optimization technique or minimization technique. The optimization problem or minimization problem can be solved by using greedy strategy. Here, the first step in the given algorithm is Initially, the starting vertex is S. Find the distance of vertex S to S. Here, the distance between vertex S to vertex S is 0. That means that the distance to the source vertex is 0. This is a self loop. Next one is assume that there is a possible way from vertex S2, starting vertex S2, remaining vertices namely A, B, C, D. And we don't know the direct path from starting vertex to other vertices. That's why simply we can consider the distance between the distance from starting vertex to remaining vertices is to be considered as a infinity. That's why the distance from S to A is infinity, S to B infinity, S to C is infinity, and S to D is infinity. So that's why the distance from the all the other vertices is to be mentioned as infinity. Set all other distances to infinity. Now here, the visited vertices is initially empty. That means that none of the vertices are visited. Visited means selected. No vertices is selected initially. So here there is a formula. This is the formula. The formula, based on this formula only, the Dijkstra algorithm will works. So to understand the formula, let us discuss an example here. Consider this is the graph. The graph can contain three vertices, namely vertex 1, vertex 2, vertex 3. So these three vertices are connected together by using directions with weights. That's why I can consider the given graph is a directed graph or weighted graph. Here, the main objective of the given graph is find the minimum cost, find the shortest path from the source vertex S to the destination vertex V. This is V. We need to find the distance from S to V. Here, initially, the distance from S to S is 0 and the distance from S to vertex 2 is 2 and there is no direct path from vertex S to vertex V. That's why the distance from vertex S to vertex V is to be considered as infinity. Why? Because there is no direct path from vertex S to vertex V. That's why we can assume and consider the distance among vertex S to V as infinity. And here, consider the this vertex, second vertex as U, and the last vertex as V. Now we can apply the formula to the given graph. This formula is called as a relaxation property. Relaxation property. Here the formula is distance of U. Distance of U is nothing but here the vertex U is 2. The vertex U is the vertex. Here 2 is the vertex. We can assume as U. So that means that what is the distance of vertex 2? The distance of vertex 2 is 2. Why? Because from 1 to 2 there is a cost or there is a distance is 2. That's why the distance of U is considered as a 2. And the cost of vertex U to V, the cost of vertex U to V is here this is the vertex U and this is vertex V. Now find the cost of vertex U to V is nothing but cost from vertex 2 to vertex 3 is the cost is 4. Here clearly mentioned that the weight is 4. Now add the distance of U plus cost of u comma v. Now we will get the distance is 6. That means that the distance from vertex S to vertex V is 2 plus 4. We will get 6. The 6 we can compare with infinity. There is no direct path from vertex 1 to vertex 3. In this case, we can consider the path size or the path capacity is infinity. If you want to find the distance from vertex 1 to vertex 3 through an intermediate vertex or through a visited vertex 2, that will take the cost is 6. So here we can find the minimum shortest path here. The minimum shortest path here, the cost is 6 or infinity. Among 6 or infinity, we can consider the minimum one is 6. That's why we can able to say that the minimum cost of the given graph is 6. The total cost from vertex S to vertex V is 6. In this way, we can solve the problem. So basically, the Dijkstra algorithm can be used in our day-to-day life to solve some important problems. Now let us see where exactly Dijkstra algorithm can be applied in the real-time scenarios. We will discuss in this session. The Dijkstra algorithm is used in traffic information systems. That means that monitoring the traffic control over the network, we use traffic information system technology that can be works based on the concept of Dijkstra algorithm, which can be used for tracking the destination from a given source location. So if you want to track the source to destination location, we can done through traffic information system that can be possible by using Dijkstra algorithm. Another application for Dijkstra algorithm is open source path first. It is an internet-based routing protocol which uses Dijkstra algorithm for finding best route from source router to other router in the network. If you want to establish a connection from one source route to a destination router, in this case, we need to minimize the route size, minimize the distance that can be possible by using this algorithm. And also, basically, Dijkstra algorithm can be used by telephone and cellular network for maintaining the routing techniques. If you want to establish a network among various cities, telephone over the telephone cables, that network minimization route or the minimization shortest path can be done by using Dijkstra algorithm. And also, Dijkstra algorithm can be used by GIS, Geographic Information System, such as Google Maps. In Google Maps, we usually use Dijkstra algorithm for finding the shortest path from a source point to a destination point. Friends, in this way, we will use Dijkstra algorithm to solve the applications in real-time scenarios. And there are some limitations of Dijkstra algorithm. Here, some of the few important limitations will be noted in this slide, which can be helpful for not use where exactly Dijkstra algorithm fails. Basically, the Dijkstra algorithm cannot support for negative edges. If the given graph can contains negative graph edges or negative weights or cost, it cannot be solved by using Dijkstra algorithm. So this is one of the limitation of Dijkstra algorithm. And second one is it does a blind search, so waste of time while processing. That means that there is a huge time will be waste while using Dijkstra. Why? Because we can do the searching for source to destination in a blind mode. So this is not the suggestible searching technique for finding the source to destination minimum cost. This is one of the disadvantage of Dijkstra algorithm. And also, the Dijkstra algorithm can lead to a cyclic graph, and most often it cannot obtain the optimal shortest path. We cannot say whether the given path is shortest path, is optimal path or not. So that's why there is no guarantee whether we will get optimal path if you solve the problem by using Dijkstra algorithm. So these are few notable limitations of Dijkstra algorithms. Now, friends, listen carefully this slide. If you understand this slide, you will be able to solve any problem. Remember the formula here. The formula is relaxation property. This is the formula. We usually apply relaxation property to the given graph. If we apply relaxation property to the given graph, what will happen? We will see. The relaxation property is here. The relaxation property is consider if this is the relaxation property. Now we can consider if distance of V. Distance of V is nothing but we need to calculate the distance of V from source. If you want to calculate the distance from source S to V, find the minimum path, minimum shortest route. So in this case, the distance from S to V, we don't know. Why we don't know means there is no direct path from S to 3. The source vertex S and the destination vertex is V, and there is no direct path from source vertex to destination vertex, and there is an intermediate node that is called as 2. If you want to travel from vertex 1 to vertex 3, you can travel through vertex 2 only. There is no direct path. Hence, if you want to travel from source to destination, so the total cost is infinity. Why we can consider the total cost is infinity means we don't know, there is no direct path. Hence we can consider as a infinity. That's why distance of V is infinity. Here you need to calculate the sum of these two values. Find the distance of vertex V. Find the distance of vertex V. Vertex U. Find the distance of vertex U. So this is the vertex U. The vertex U distance is 2. The distance of vertex U is 2. Why? Because from S to 1 to 2 there is a cost 2. That's why we can consider this is a distance of U is 2. We can consider, and the cost of U to V, and this is U is one vertex and this is third vertex V vertex. The cost of vertex 2 to vertex 3 or vertex U to vertex V is 4. That's why we can consider the cost of vertex V to vertex U to vertex V is 4. Now apply sum of what distance of U plus cost of U comma V, that is equal to, we will get the result is sum is 6, we will get 6. Now compare 6 with infinity, which one is smaller? 6 is smaller. So that's why the minimum cost for source to destination is 6. In this way, you can consider or you can find the minimum cost of the given graph. So, friends, here we will see if you want to find the distance from vertex 1 to vertex 1. If you want to find the distance from vertex 1 to vertex 1, there is a self loop will be formed. That means that the distance from vertex 1 to vertex 1 is to be considered as a 0 b. That means that there is no path established here. That's why the distance is c 0. The distance from vertex 1 to vertex 2, if you want to find the distance from vertex 1 to vertex 2, the distance is 2 here. There is a direct path here. It is a direct path here. That's why we can consider this one. If you want to find the distance from vertex 1 to vertex 3, if you want to find the distance from vertex 1 to vertex 3, there is no direct path established. That's why we can consider the distance is infinite. We can consider the destination from vertex 1 to 3 is infinite. Why? Because there is no direct path established from vertex 1 to vertex 3. So if you want to find the minimum distance from vertex 1, that is source vertex, to vertex 3, then we simply apply relaxation property. Relaxation property is nothing but this is the relaxation property. We can simply apply the property, check whether the terms are accepted or not. Then only we can get the minimum solution. The minimum solution is 6. In this way, you can solve the problem. Okay. So next, we will discuss the same problem with another example here. Just a minute, I will erase all these. Now consider a simple example here. You can solve the given problem by using Dijkstra algorithm. In the given problem, there is a graph. The graph is a undirected weighted graph. This is called as a, the given graph is undirected weighted graph. Why I am calling this is a undirected weighted graph is where it is, yeah. So I can consider this is a undirected weighted graph. So why I am considering this is undirected weighted graph is there is no directions from S to A. It is a dual mode. You can go from S to A or A to S. There is no specific direction. That's why we can consider as a undirected. And why we can call as a weighted graph is nothing but so there is a source to destination here. Formats. Profit. Select here. So if you want to select from source to destination S to A, there is a weight, a path established with a weight of 9. Here from S to C, the path is 5. If you consider C to D, the weight is 4. So that means that this is called as a weighted graph only. Now, we can solve the given problem. Find the, by using Dijkstra algorithm, how we will see. The given problem is find single source shortest path from vertex S to other vertices. So that means that you can solve the problem in a stage-wise manner by applying greedy strategy to minimize the distance from source from the starting vertex S to all the remaining vertices in a stage manner. If you want to find the minimum cost or minimum distance from starting vertex S to stage 1, so there are two vertices A and B. So we can find out in stage 1, we can find out the in stage 2 also. In this way, we can find out the minimum cost, minimum cost or distance from source to destination in this way. Now, how we will discuss how to solve the problem. Now, see how to solve the problem. Consider first select the first vertex. Select the first vertex. Here, the first vertex I have selected is it is Now consider, first select this vertex, namely S, and this is the first vertex, and S2S, if you want to find the shortest route from vertex S to vertex S is 0. Vertex S to vertex S, the cost is 0. And here the first row indicates visited vertices, whereas the second row indicates the cost among various vertices. So here vertex S to vertex S, the distance is 0. And what is the distance from vertex S to vertex A? If you want to find the distance from starting vertex to the second vertex A is, here I have mentioned infinity. Why I have mentioned infinity is, in the initial stage itself, you can assume that the distance from vertex 1 to vertex 1 is starting vertex is 0. The distance from starting vertex to all other vertexes is to be set as infinity. ఫస్ట్ వర్టెక్స్ కి డిస్టెన్స్ 0 ఉంటుంది. రిమైనింగ్ వర్టిసెస్ అన్నిటికీ డిస్టెన్స్ అనేది ఇన్ఫినిటీగా మనం సెలెక్ట్ చేసుకుంటాం ఇనీషియల్. దట్ ఈస్ ద ఫస్ట్ స్టెప్. ఇనీషియల్ గా సెలెక్ట్ చేసుకున్న తర్వాత నెక్స్ట్ సెకండ్ స్టెప్ ఏంటంటే సో హియర్ ద డిస్టెన్స్ ఫ్రమ్ S to A, I don't know, there is S to A డిస్టెన్స్ మనకు తెలియదు, సో ఇన్ఫినిటీ అని పెట్టేసాం. సో డిస్టెన్స్ ఫ్రమ్ S to B, నెక్స్ట్ వీ నీడ్ టు ఫైండ్ డిస్టెన్స్ ఫ్రమ్ S to B, set as infinity. Next, set distance from S to C, set as infinity. Next, set distance from S to D is infinity. That means that initially you can set the distance from S to S is 0. The distance from source to other vertices is to be simply set as infinity. So this is the first step. Now move to another slide. Here the visited vertex is S. The visited vertex is S. That is nothing but this vertices is already visited. అంటే సెలెక్టెడ్. ఈ వర్టిసెక్స్ ని మనం ఆల్రెడీ సెలెక్ట్ చేసుకున్నాం. ఈ వర్టెక్స్ ని సెలెక్ట్ చేసుకున్న తర్వాత దాని యొక్క కాస్ట్ అనేది 0 ఉందండి. ఐ డోంట్ నో కాస్ట్. అండ్ ఫైండ్ ద డైరెక్ట్ పాత్ ఫ్రమ్ S to A. S to A డైరెక్ట్ పాత్ ఉంది. దెర్ ఇస్ ఏ డైరెక్ట్ పాత్ ఫ్రమ్ వర్టెక్స్ S to వర్టెక్స్ A. దాని యొక్క కాస్ట్ S to A, there is a direct path is there with a cost of 9. And there is a direct path from vertex S to vertex C also. There is a direct path from vertex S to vertex C of cost is 5. There is a direct path from vertex 1 to vertex C. The direct path is 5. And there is no direct path from vertex S to vertex B. There is no direct path from vertex S to vertex B. That means that here there is no direct path. Here from vertex S to vertex B, there is no direct path. Hence, we can consider the vertex S to vertex B distance is, just a minute. Can consider the distance from vertex S to vertex B is, we can set this one as infinity simply. And also there is no direct path from vertex S to vertex D. That's why we can consider the distance from vertex S to vertex D. Also there is no direct path from vertex S to vertex D also. That's why we simply consider as a infinity here. So in this way, you can fill the visited vertices. Okay. So this is the first step. Next step is we can move to we can move to the next slide. So here filling of the visited vertex is already over. The first vertex yes is visited, and also we can find there is two paths. There is two paths available here. One is S2C. So I will tell you there are two paths available here from vertexes. There are two paths. The first one is S2A and second one is S2C. S2A and S2C. And S2A, what is the distance? S2A, the distance is 9. And S2C, what is the distance? And 5 here. So S2A, the distance is 9. And S2B, the vertex S2B, the distance is 5. So here, the minimum cost is this one. So hence you can select the path is S to C. So hence you need to select the path as you need to select the you can select the path as S to C here. So this is already visited node. Select the shortest path is S to C. So if you select the shortest path S to C, then only find the path from S to A. If I want to find the path from S to A, initially what is the path from S to A? There is a direct path from S to A, that is 9. If you want to move from S to A, there is a direct path from S to A, we will get the weight is 9. But always find the minimum weight. And what is another possible way? Move from S to A. There is a possibility you can move from S to A through intermediate node. There is a possibility you can move from S to A through intermediate node. That is from S to C and C to A. You can move from S to C and C to A. That means that if you want to move from S to C, the cost is 5, and from C to A, the cost is 2, and total cost is 7. Total cost is 7. And if you want to move from S to C through the intermediate node S to A, if you want to move from S to A through the intermediate node C, the cost is 7. Now here, which one is smallest? 7 is smallest, and this is not the smallest. Hence, you can consider the smallest path is 0 to S2A smallest. Hence, consider the smallest path from S2A is 7, not 9 in this case. So, like that only, if you want to find the direct path from S to B, if you want to find the direct path from S to B, there is no direct path from S to B. That's why we can consider as infinity. If you want to find the direct path from S to B through an intermediate node C. Here C is an intermediate node. If you want to find the direct path from S to B through intermediate node C, S to B through intermediate node C, that is called, go to here and we can move from here to here. What is the cost? 5 plus 9? 14. We will get the value is 5 plus 9, we will get the cost is 14. Now we can compare infinity with 14. Which one is minimum? 14 is minimum. we can consider this one, we can ignore this one in this case. Next, find the direct path from S to C. So S to C, there is a direct path. No need to do here. If you want to find the direct path from S to D, you want to find the direct path from S to D. S to D, there is no direct path. There is no direct path from S to D. That's why it is considered as a infinity here. If you want to find the path from S to D, if you want to find the path from S to D through an intermediate node C, through an intermediate node C, from S to C, then move C to D. The total cost is 5 plus 4, that is equal to 9 we will get. Now compare 9 with infinity, we will get the minimum is 9. Hence we can consider this is the best answer here. Okay. Next, here vertex S is already visited. The path from S to all remaining vertices will be mentioned here. Vertex C also visited. That means that already two vertices are visited here. Vertex S is visited. Vertex C also visited. And vertex A. Now we go for vertex A. Visited. And if you want to find A to vertex S to A, from vertex S to vertex A, if you want to find, basically the distance is 9, but we will see through intermediate node C. Through intermediate node is C. If you want to move from vertex S to vertex A through intermediate node C, so vertex S to vertex C, then move to A. The total cost is 5 plus 7. Okay. So next we can consider this, we can find out vertex S to vertex B. Find the shortest route through intermediate vertex C. So అంటే vertex S నుంచి vertex B కి మూవ్ అవ్వాలి, త్రూ C ద్వారా మూవ్ అవ్వాలి. S నుంచి B కి మూవ్ అవ్వాలి, vertex S నుంచి B కి మూవ్ అవ్వాలి, త్రూ S నుంచి B కి త్రూ C ద్వారా మూవ్ అవ్వాలి. టోటల్ కాస్ట్ అంతా 9 plus 5 14 వస్తుంది. 9 plus 5 14 వస్తుంది. But S2 B, S2 vertex S2 vertex B is through vertex S2 vertex B to C, to C 5 plus 9 48. Just a minute. Vertex S2 vertex B. So vertex A की 4 ఎలా వస్తుంది? S2 C4 here is S2 C4, S2 C4. Here are the right here. Vertex S2 vertex A, vertex S2 vertex A 7. Now here you can consider this one. If you want to consider from vertex S to vertex A, 7 and 8. So how it is, we will discuss here. If you want to move from vertex S to vertex S, this is 0. Vertex S to vertex A, if you want to move from clear all, if you want to move from vertex S to vertex A, vertex S to vertex A, if you want to move 7, how it is, through C we can move 5 plus 2, we will get 7. If you want to move vertex A to vertex B, so through intermediate, vertex S to vertex B. So through intermediate is C. Through intermediate is C comma A. Intermediate ఇక్కడ 2 nodes ఉన్నాయండి. Intermediate nodes C comma A ఉన్నాయి. So అంటే 1 to 5 ఇది ఒకటి. Next move here. Next C కదా vertex A, vertex S to C, C to A, then A to B, then A to B. Now find the total cost. 5 plus 2 plus 1. 5 plus 2 plus 1. Total cost is 5 plus 2 plus 1. 8. We will get the total cost is 8 here. Now we will see total cost from vertex A to vertex C here. Through intermediate vertex is C comma A. S నుంచి C కి మూవ్ అవ్వాలి C comma A. S నుంచి C కి మూవ్ అంటే C comma A is minimum is ఇది. So ఇది కూడా క్లారిటీ అయిపోయింది. Next we go for finding the cost from D. Vertex S to vertex D. So vertex X to vertex D through intermediate nodes C comma A. So S to C, C to A, and then A to D. So A to D, there is no path from A to D. So that's why we can go for CA 9, 5 plus 4. So we can find out 5 plus 4 is the minimum one. So this way we can find it. Next, this is the final one. If you want to move from vertex S to vertex D, vertex S to vertex D, two intermediate nodes are C comma A comma B. C comma A comma B. These nodes are visited. All nodes are visited. If you want to move, so the values will be generated in such a way that all the nodes are visited here. So here S to S0, S to A is 7, S to A is through 7 means how it is. In this way we can move here. And 8 means 5 to 6, we can move here. And 9 means 5 plus 4, we can move here. That means that the total weight is in this way. So here, this is the first node, and this is level 1 nodes, and here these are level 2 nodes. If you want to move from vertex 1 to level 1 node, there is the cost is 5 plus 2, 7. So the vertex 1 to the level 1 node C is the cost is 8. How it is 5 plus 3. The cost is B కావాలంటే 5 ప్లస్ ఇలా Bకి మూవ్ అవ్వచ్చు. సో Cకి మూవ్ అవ్వాలంటే 5 నుంచి Cకి డైరెక్ట్గా మూవ్ అవ్వచ్చు. Dకి మూవ్ అవ్వాలంటే S నుంచి Cకి, C నుంచి Dకి మూవ్ అవ్వచ్చు. ఈ రకంగా మనం వాల్యూస్ని ఏదైనా డిగ్రీగా చేసేసుకోవచ్చు అనమాట. నెక్స్ట్, దిస్ ఈస్ ద ఫైనల్ resultant matrix, and this can be generated from the given problem. We need to find the minimum cost from starting vertex to all the remaining vertices. The problem can be solved through the greedy strategy here. So here you consider the starting vertex is S, and this is the starting vertex S. And if you want to move from starting vertex to the, this is level 1 vertex. So what is the minimum cost from S to A? S to A minimum cost manaki vellalante, so we can go from S to C, C to A. S to C, C to A move అయితే 5 plus 2. ఇక్కడ 5 here, 2 size is 7 వస్తుంది. Instead of 9, 7 వస్తుంది. C రకంగా move. If you want to move from S to C, there is a direct path from S to C. Half cost, total cost is 5. If you want to move from S to, if you want to move from S to B, there is no direct path from S to B. In this case, you can move from S to C because this is the shortest path, and C to A, this is another shortest path. Then A to B, this is another shortest path. So in this way, we can move from S to B. The total cost is 5 plus 2 plus 1, 8. So in this way, you can move here. If you want to move from source node S to D, so there is a direct path from S to C and C to D, S to C, C to D. So friends, there is always you can find out the shortest route from source node to all the remaining nodes as per the given table. In this way, you can solve the problem clearly. So in this way, you can solve the problem clearly. So thank you. So this problem is very useful for you, and it is very important for you to solve the given problem. And we will discuss another problem, how to solve using Dijkstra, in next class. Thank you. Thank you.